Hello everyone. Today we are going to discuss about the concept application level multicasting. First of all, we will see the concept of multicasting. So whenever we want to send a message from a particular source to multiple recipients, we consider use of networks and we multicast the message. Whenever we consider the message sent from a particular source to a particular destination considering a pair of nodes, it is considered as a traditional unicast in which it will consider the pair of nodes in the selected graph. Now, when we are considering multicast, it will consider the minimum weight tree that spans all the nodes in the multicast graph. Okay. Now, when we want to consider the comparison between the one-to-one operation of the unicast and one-to-all of the broadcast, there will be some common points. Firstly, multicast is growing up steadily with the increasing number of applications. You can consider the instance of internet broadcasting, video conferencing, data streaming, and web content distributions. Now we will see the difference or the comparison between the IP multicast and application level multicast. In the IP multicast, it adds special functionality in the routers of the core network. It makes efficient use of the network resources. Whereas if we consider the application level multicast, it provides control functions at end host. Also, it is very easy for deployment and it requires few or no network updations. Now we will discuss the difference between IPM and ALM considering the diagrammatic representation. You can see here in this diagram, we are focusing on the forwarding of the packets through the use of IPM and the ALM. We are considering the forwarding paths for the comparison. Here A and B are considered as the routers and there exist the thin connector lines which are nothing but the physical links. Here the end host S sends multicast data to all other end hosts like R1, R2 and R3 in both IPM and ALM. Now we will focus on the first diagrammatic representation which considers the IPM, IP multicast. Now here the sender S sends one packet at a time and it reaches the destination through replication of packets at A and B routers. Exactly one copy of packet is considered for traversal through this physical link and it will avoid the duplicate packet transmission on the physical links. In ALM, we are considering the end hosts are forming a logical overlay network on which the application level multicasting tree is constructed. Here S sends a packet to R1 and R2 directly and R2 will replicate it for forwarding it to the R3. Here packet replication and forwarding are implemented at the end hosts. Now in this ALM, all packets are transmitted considering them as the unicast packets and it considers two performance penalties. Firstly, the link SA duplicates copies of the packets. Second, the data delivery path from S to the R3 will include the redundant round trip between B and R2. Now, if we consider the transmission of packets, either considering the ALM or the IPM, there can be the consideration of packet drop rates and the mean link stress. So we are considering the graphical representation of that particular packet drop rates for ALM as well as IPM, considering on the x-axis average number of hangovers and on the y-axis the packet drop rate. In the second diagrammatic representation, we are considering the link stress comparison for ALM and IPM. Here, group size is considered on the x-axis and the mean link stress is considered on the y-axis. Considering it, we are graphically representing the IPM multicast and the ALM multicast. Now we will focus on the various ALM functionalities. Firstly, it will accelerate the deployment. Next, it is a easy configuration, and we are considering the better access control by involving the additional traffic load in the network through overlay based approach. If we have to consider the ALM architecture, we will focus on the general approach for building it, considering the few important parameters like tracking network characteristics, building appropriate topologies, having the end users to self-organize into logical overlay networks, and efficient data delivery. Now, when we are considering all these parameters, we will discuss in brief how all these parameters work. When we are considering the data delivery, it is performed via a data delivery tree, which can either be the overlay itself or it can be embedded in the overlay. Again, the overlay must be capable of failure detection and it will attempt to match the underlying network topology. ALM is also considered as end system multicast or post multicast. Reason is here the overlay abstracts away the details of multi-point message forwarding through the network. It also implements them at end users. For all this discussion, I have referred this as the references. Thank you all.